So for the last few weeks I've been working on a couple of new projects. Those of you that are familiar to the channel and regulars here, you'll probably have seen some of my custom build projects where I build some pretty crazy looking systems with case mods and custom water cooling. I've got another one of those coming up. This time we'll be working in partnership with Fractal Design and scan.co.uk. That's currently work in progress. There'll be more information on that soon, but today I'm doing something a bit new to the channel, something that is quite close to my heart, something that I've been really enthusiastic about for as long as I can remember, messing with PCs when I was a kid. I've always been interested in getting every last little bit of performance out of the system, making sure I'm getting every bit of value for money that I possibly can in terms of performance, and also making sure the system is running, or at least the CPU is running as cool as possible. Ever since the Intel 12th gen launch, we've seen a few things where CPU temperature has been a problem for certain people. I know there's been some pre-built system vendors that are having problems cooling the 12900K with certain all-in-one CPU coolers. I know when Leo reviewed the 12900K, wasn't overly impressed with the thermal performance as soon as you started to run the CPU past its stock configuration. Over the last couple of weeks I've been working closely with EKWB, trying to come up with some kind of solution to this problem. I'm not talking about a CPU socket mod or adding washers to retention bracket or something like that. That's already been done. We've seen all about that. What we are looking to do is bring something, or look for some kind of solution for real enthusiasts that want to run a custom loop and want to push the 12900K to its limits. And I guess since the launch of the 12900KS, that's going to be even more relevant. So I've been working closely with EKWB, and we're looking at direct die cooling. So that's going to involve delidding the CPU, removing the stock retention bracket, making a die guard, and then either modifying or making a new direct die water block. So EKWB are currently working on that side of things. So we've developed a water block for direct die cooling of Intel 12th gen and a die guard as well to hold the CPU in place, because obviously we'll have to remove the stock retention bracket. So it should be an interesting one. Before we can get on to the delidding of the CPU and all the fun stuff of the direct die cooling and modding, we need to take a look at the CPU in its stock configuration with the stock IHS and see what kind of thermal performance we get with it. So I'm just going to run some tests now with the CPU almost at its Intel default, so as close to that as possible, and then run a manual overclock myself, see how far I can push this CPU. So just before we dive into any thermal testing, I just want to give you a quick rundown of what we've actually got on the test bench. So I've done a bit of a mod to this test bench so that I can hold this 360 rad in place and mount the pump res combo on there. Motherboard is the Asus ROG Maximus Z690 Hero. Intel Core i9 12900K CPU, obviously. The memory is Corsair Dominator Platinum RGB DDR5. This is the 6000 MHz C36 kit. Graphics card is an RTX 3080 Aorus Master. Thinking about that now, it's a bit overkill because we're only just going to be using it to output a display, but it's there anyway. And you can see a custom loop we've got installed as well. So a 360mm EK Coolstream P radiator. This is the 40mm radiator, and a EK Velocity 2 water block. So this is specific for LGA 1700. Fans on the radiator are Noctua A12 X25s, and the pump res combo is a EK Quantum Kinetic DDC pump res combo. So that's basically the test system. You can see I've just installed these quick disconnects as well, because obviously between delidding and swapping things over, it's going to be easier using the quick disconnects rather than draining everything down. So that's the test system. Let's have a look and see what the thermal performance is like with the CPU with its lid on. So to test the thermals of the 12900K, I wanted to run the CPU in two different configurations. One as close to Intel stock configuration as possible, and then my own manual overclock. So I just want to run you through what I've got in the BIOS. So currently we're looking at the profile that I've saved for the CPU in its almost default state. Most things have remained unchanged in the BIOS. The defaults for things like the B-clock, PCIe frequency, adaptive boost technology remain at default. I have enabled the XMP profile for the memory, obviously. So the Corsair Dominator Platinum is running at 6000 megahertz. One thing that I did change was the Asus multi-core enhancement. The default for that is auto, lets the BIOS optimize, and I found during the stress tests with that set at auto, the CPU package power was doing some really freaky things, boosting right up to 270 watts, which didn't sound anything like default at all. So I enabled the multi-core enhancement, and then package power was more consistent around 240 watts with that enabled. And as you can see, everything else is pretty much set to auto. The P-core ratio and the E-core ratios, they're all on auto. In the DigiVRM, everything again is pretty much on auto. No load line calibration, that's just set at auto. Auto is at level 3, but as you can see, more or less everything is pretty much at auto. The V-core, that's all at auto as well, and also the CPU input voltage as well, which is the voltage sent to the Fiverr on-chip voltage regulator that's actually on the CPU. As you can see, everything else pretty much on auto. Also during the thermal testing, I'll have the fans, the Noctua fans on the radiator and the pump all set to a fixed speed for consistency. I can just load up another profile for the overclock. Go to the extreme tweaker section again. You can see XMP still enabled. B-clock frequency remains untouched. Adaptive boost I've disabled because I want to keep the frequency at its maximum speed at all time. Multi-core enhancement, that's still enabled, but it doesn't do much when you've tuned in a manual overclock anyway. DRAM frequency 6000, and then if you look at the performance core ratio, you see I've got that set at 52, so that will be all the P cores running at 5.2 gigahertz, and the E cores, the frequency ratio on that is at 41, so that will be 4.1 gigahertz on the E cores. If I go into the DigiVRM section, load line calibration I've set at level 6, and then power management, basically maxed out everything on the power management, so the current limits and the long duration and short duration package limits. Thermal velocity boost, I've disabled all that again because I just want the frequency to stay at the fixed 5.2 gigahertz. And then if we just scroll down a bit further, you can see that the CPU V-core I've set manually to 1.33 volts. CPU input voltage I didn't need to change in the end. I thought I might have to bump that up to maybe 1.9 volts, but the CPU was stable. So back into Windows, and we're running the stock BIOS profile, so the one that's closest to the Intel defaults, and you can see in the background Cinebench R23 is running in a loop constantly as a stress test, and you can see on the Intel XTU software, package power is around 205 watts, CPU utilization 100% while the test is running, core voltage is around about 1.2 volts, and the P-core frequency is 4.9, you can see on there, and on the HW info, P-cores are at 4.9 and the E-cores are at 3.7, so that's basically the Intel stock frequency. And the CPU temperature has reached steady state, and it's around between 70 and 75 degrees C. I've run some other tests and logged all the data, but I thought it'd better for the video for you actually to see it on screen as it's happening. You can see on these HW infographs the higher package power and temperature here. That was during a Prime 95 run. The Prime 95 pushes the package power right up to 265 watts, and during the Prime 95 runs we were seeing CPU temperature around about 85 to 86 degrees C. Now I've just switched to the other BIOS profile with my own manual overclock, and you can see the P cores are running at 5.2 gigahertz and the E cores are sat at 4.1 gigahertz. The CPU V core voltage is fluctuating between 1.29 to 1.3 volts. We've got the load line calibration at level 6, so it is still a bit lower than what we actually input in the BIOS at 1.33, but it's stable on the R23 stress test. This stress test is again running in a loop continuously, and you can see the CPU package temperature is around about 90 degrees C, and it hits that steady state temperature really quickly. We've only been running this stress test for about 5 minutes. You can see it's already up to 90 degrees C, and it just peaks. It seems to flatline at that 90 degrees C no matter how long you run this. I've run this test in my additional testing for an hour plus, and still 90 degrees C is the steady state. You can see package power now is 265 watts. So 5.2 gigahertz seems stable in terms of Cinebench R23. I like to use Cinebench R23 for a stability test. I did manage to push the CPU frequency to 5.3 gigahertz on the P cores. The system did post. I had to tweak the voltage a little to 1.34 volts, but stability was questionable, so I'm going to stick with 5.2 gigahertz as the maximum overclock that I can achieve with the CPU in its current configuration. Maybe when it's delidded and direct die cooled, potentially with more efficient cooling, we might be able to push the overclock a little higher. But the main thing really for us is seeing how the direct die cooling affects the temperature. So at the moment, with the lid on, in its stock configuration, overclocked to 5.2 gigahertz, we're looking at 90 degrees C on the CPU package temperature. So currently there's not a lot of 12th gen Delid tools out on the market to choose from. In fact, when I started planning this project, there was zero, and we were thinking maybe part of the project would be to design our own Delid tool. But thankfully I was looking around a couple of weeks ago, and a company in the US called Rocket Cool has now released their own Delid tool for 12th gen. I've got it here. It costs about $60 in the US. Obviously, if you want shipping to the UK, it's going to bump the price up a bit more, especially if you want the express shipping, but it's still worth it. I have used one of their tools before. I used one on a Skylake Delid. It was the one that kind of twisted the IHS off, and that was good quality, worked well. This one seems the same. I've actually practiced on an i3 12100F. That was successful. This is the tool. It comes in two pieces. It looks like it's made out primarily from acetal, and it's got looks like an aluminium slider there. You tighten the nut up onto that, and that should push off the IHS. It also comes with kind of a jig if you want to relid as well. We'll not be using that because we're not relidding, and it comes with a couple of nuts and bolts and a couple of high tensile Allen keys as well. And also you get a little kit as well for cleaning off the old indium solder. So we've got the 12900K back out of the system. I've just put it on here to protect my work surface from heat, but because the indium solder on the 12900K is pretty soft, you don't have to heat it up too much to delid the CPU. So you might have seen people delid these. There's plenty of videos of 12th gen being delidded, but I'll just quickly show you how it's done with this tool. Other than what's provided in the kit, you don't need a lot of tools to delid a 12th gen CPU. You might want to heat up the IHS just to soften up the adhesive a bit. So I'm just going to use a heat gun on a medium heat just to warm up that adhesive a bit. It's quite cold in here. So that should be enough heat. You just have to be careful now because this will be quite warm. And now you just need to make sure that the slider is all the way back on the Delid tool, and then line up the arrow with the arrow on the CPU. And then just make sure that's nice and flat in position. Put the top on here, make sure the slider doesn't get in the way, and put these 3 Allen screws in. There's no need to tighten these up really tight, just give them a quick nip up so that the thing can't move about. And then once the CPU is in there, all you need to do now is tighten down on this slider until you hear the IHS move. You can just hear it. It kind of makes a bit of a cracking, creaking noise. So once it has done that, just tighten it up a little bit further. And that should have pushed it all the way off the IHS, all the way off the die. And you can just loosen that back. Take the Allen screws out again. And you can see it looks like we've got a successful Delid. I'm just going to clean off the adhesive just with this wooden scraper that comes in the kit, and then I'll show you how to remove the rest of the indium solder that's left. The IHS as well, you clean it up in the same way, but we're not going to be reusing that IHS. So I'll clean this off and then come back and show you how to remove the leftover solder. So I've just scraped off all the adhesive with the little wooden scraper that comes in the kit, and then got rid of the leftover residue with a bit of isopropyl alcohol. When it actually comes to running this CPU with direct die cooling, I'm going to be using some conductor note liquid metal for the thermal interface material. So I need to remove the leftover indium solder. You might find that this wooden scraper does scrape this off as well, so you can at least get the kind of the thick layer off, but you just have to be careful to a certain extent. You don't want to push on too hard and crack the die or scratch the die or anything like that, but you can just work at the thick layer of indium that's left. Scrape as much of that off as you can, and then I'll show you what you can do with the rest as well. You can see it's really soft, this solder. It does scrapes off quite easily actually. You can probably, if you want to, use like a razor blade or something like that, but you do have to take extra care if you're using a razor blade, because there is, again, a bit more potential that you could do some damage to the die if you scratch it wrong. But I like to just get off the majority of the thick stuff with this wooden scraper, and then use a chemical to remove it. It actually comes in the kit. It's Rocket Cool call it Quicksilver. It comes in a little syringe like you get your thermal interface material in, and actually if you don't have some of this but you do have some leftover liquid metal, you might find that liquid metal will remove this indium solder just as easy as this Quicksilver does, because I've used it before when I've run out of this, been able to use some liquid metal, and it just dissolves the stuff. So it's probably a similar chemical makeup, this Quicksilver, as the liquid metal is. So you just take this Quicksilver, and just blob a bit of it on top of the CPU. It might be a bit much. You can also use this to clean off the IHS as well, and then you take one of these Q-tips that comes in the kit as well, and just rub it round again like you do with the liquid metal. Rub it against the indium solder and it will dissolve it. So just give it a good rub round. You can actually feel it getting smoother as you do it. So the more you rub on it, the smoother it feels, the more you know that you've removed the indium solder underneath. So once it feels nice and smooth, which it does now, You can just hold on for a minute, get a bit of something to wipe it away with. Try and wipe as much of that away as you can, and then with the majority off, a bit more isopropyl alcohol on the CPU. So try and clean everything off the PCB again. I'll just pop this back in the Delid tool just to hold it easier, and you can see now that the majority of the indium solder has been removed. There are still a little bit here and there, so I'm just going to use a little bit more of this again. Just try to get rid of the last remaining pieces that are there. And just give it a final wipe down with a bit more alcohol. So you can see virtually all the indium solder is removed now from the CPU die. It does leave behind like a tainted residue on the die, and we want to clean that up so it's back to its factory kind of mirror finish. So also in the kit you get with the Delid tool, you get a bit of polish. It's just like a metal polish, and you can use this to just shine it back up, get rid of the leftover dull residue. Pop a bit of that polish on there and just polish it up till it comes back to a nice shiny finish. So that's it. You can see we're really back to the bare die now, nice and shiny polish finish to it. And then just to clean off any potential residue left over by the polish, again, a little bit of isopropyl alcohol for a final clean to just get rid of any contaminants on the surface. So that's it. That is the Delidded 12900K. Pretty simple process actually. The indium solder is that soft, it doesn't need a lot of heating. You don't need a lot of tools. Everything comes in the kit from Rocket Cool. When you tighten it up and moving the IHS off, yes, it does feel like something could be being damaged or something, but it works perfectly fine. I've done the 12900K and the 12100F, both so far look successful. I've not tested them on the system yet, but I'm pretty confident that's worked perfectly fine. All we're waiting for now is the die guard and the direct die water block to come from EK. As soon as those arrive, we'll be sticking the 12900K back on the test bench and seeing, for one, if it works after the Delid, and then see if we can improve the thermal performance. Obviously, like I said, going to be using some conductor liquid metal on there, so there's a couple of very tiny resistors either side of the CPU die, which I'll probably try and insulate with some nail polish or something like that. But that's basically it, ready to go now. We're hoping we're going to see a good improvement in the thermal performance with direct die cooling. I have seen one or two other videos of people delidding using liquid metal and then relidding again, and they've seen significant drops in the temperature. We're hoping to take that one step further with direct die cooling. And if we're not successful, and then at least we've saved you the trouble of trying it out, you can come and refer to our video before you give it a go yourself. But I'm pretty confident that we're going to see some good results, and if this does turn out to be a big success, EKWB is talking about releasing the direct die water block to the public maybe later on in the summer as well, along with the die guard. So hopefully we can get a direct die cooling kit out on the market to enthusiasts that want to delid their 12900Ks or 12700Ks or any 12th gen CPU for that fact. So hopefully it's going to be a success. We'll find out very soon. So that's where we're going to have to end this video. We'll be back as soon as we can with the direct die water block and the die guard to continue on with the project and see if we do get some significant improvements in the thermal performance. So I hope you enjoy watching this video. If you have, don't forget, hit the like button, subscribe to the channel. If you want to help support Kit Guru, if you like what we do, you can head over to our store, pick up some of the Kit Guru merchandise. You can also subscribe to our Patreon. And as always, if you want to catch up on all the in-depth technical reviews, head over to the website.